The morning mist clung to the rice paddies outside Da Nang as Sergeant First Class Robert Mosbacher of the U.S. Army Special Forces adjusted his grip on the familiar wooden stock. The weapon in his hands weighed exactly 5.2 pounds, unloaded nearly 4 pounds lighter than the standard-issue M1 Garand rifle most American infantry carried. But this wasn't 1945 in the Pacific Theater. This was 1962 in South Vietnam, and the little carbine that had armed rear-echelon troops against German panzer crews was about to face an entirely different kind of war. What Mosbacher couldn't know, crouched in that elephant grass with his Vietnamese counterparts from the Army of the Republic of Vietnam, was that his weapon represented the beginning of the most massive small arms transfer in Cold War history. Over the next 13 years, the United States would deliver 793,994 M1 and M2 carbines to South Vietnam, more individual weapons than the total number of American combat troops who would ever serve in country simultaneously. The carbine's journey to Southeast Asia began not in the jungles of Vietnam, but in the industrial heartland of America during World War II. Between June 1942 and August 1945, 10 primary contractors had manufactured over 6.1 million M1 carbines, making it the most produced American small arm of the Second World War. The largest single producer, the Inland Manufacturing Division of General Motors in Dayton, Ohio, had turned out 2,632,097 carbines, 43% of total wartime production. But mass production numbers tell only part of the story. The real revolution lay in the weapons design philosophy, developed by a team at Winchester Repeating Arms under engineer Edwin Pugsley, in just 13 days during the autumn of 1941. The carbine employed the short-stroke gas piston system invented by David Marshall Williams, a convicted murderer who had designed the mechanism while serving time at a North Carolina prison farm. Williams' innovation would prove prophetic. A weapon born from desperation, refined in captivity, and destined to arm both sides of America's longest war. By 1954, when the French withdrew from Indochina after their defeat at Dien Bien Phu, thousands of M1 carbines had already entered Vietnamese hands. The French forces, equipped with American Lend-Lease weapons since 1950, had distributed carbines to colonial troops and auxiliary units throughout their 8-year struggle against Ho Chi Minh's Viet Minh. When the Geneva Accords partitioned Vietnam at the 17th parallel, these weapons didn't vanish. They filtered south into the hands of the newly established Army of the Republic of Vietnam, and north into Viet Minh arsenals that would later supply the National Liberation Front. The irony was profound, though few recognized it at the time. A weapon designed to arm American support personnel, radio men, truck drivers, artillery crews, was becoming the primary infantry rifle for the world's newest nation. South Vietnamese President Ngo Dinh Diem's forces, smaller in stature than their American advisors, found the lightweight carbine ideally suited to their build. At 5 feet 2 inches tall on average, an ARVN soldier carrying a 9-pound M1 Garand looked almost comical. The same man with a 5-pound carbine appeared properly equipped for war. This anthropometric reality drove American supply decisions throughout the early 1960s. Lieutenant Colonel Francis Kelly of the 5th Special Forces Group, writing in his after-action report from 1964, noted that indigenous personnel consistently preferred the M1 and M2 carbine over the M1 Garand rifle, citing not only weight considerations but superior maneuverability in jungle terrain. The preference wasn't merely physical, it was tactical. Vietnamese soldiers, whether north or south, had grown up in dense vegetation where engagement ranges rarely exceeded 200 meters, well within the carbine's effective range. The weapon's widespread adoption by South Vietnamese forces began in earnest during 1963, as President John Kennedy expanded the Military Assistance Advisory Group's training mission. Captain Dale Dye of the U.S. Marine Corps, who would later serve multiple tours in Vietnam, recalled encountering his first ARVN unit, equipped entirely with M1 carbines near the Mekong Delta in January 1964. Every man in the company carried one, Dye remembered. They moved through that terrain like water, and the carbines never seemed to slow them down. The numbers behind this transformation were staggering. According to declassified Department of Defense logistics reports, carbine deliveries to South Vietnam accelerated dramatically after the Gulf of Tonkin incident in August 1964. In 1965 alone, the United States shipped 112,500 M1 and M2 carbines to ARVN forces, regional forces, and popular forces units. By 1968, the peak year of American involvement, South Vietnamese forces had received over 500,000 carbines of various models. But the carbine story in Vietnam extends far beyond American supply manifests. Nguyen Van Ton, a former regional forces platoon leader interviewed by military historians in 1998, provided insight into the weapon's role from a South Vietnamese perspective. The M1 carbine was not just our rifle, it was our identity, Ton explained. We could field strip it blindfolded, manufacture spare parts from scrap metal, and keep it firing in conditions that would disable American weapons. When you carried a carbine, you were a soldier. Ton's unit, the 3rd Regional Forces Company operating in Binh Dinh Province during 1966, had received a mixture of M1 and M2 carbines through the Military Assistance Program. The selective fire M2 variant, capable of both semi-automatic and full automatic fire at 750 rounds per minute, proved particularly effective in defensive operations. During the night attacks, the full auto capability saved our positions multiple times, Ton recalled. The sound alone, that distinctive rapid fire, would break up enemy assaults before they reached our wire. The technical specifications that made the carbine appealing to South Vietnamese forces also caught the attention of their enemies. Vo Nguyen Giap's People's Army of Vietnam had captured significant numbers of French-issued carbines during the First Indochina War, and intelligence reports from the 1960s indicate that Viet Cong units actively sought to acquire more through battlefield capture, black market purchases, and raids on ARVN armories. A captured North Vietnamese Army document, discovered during Operation Masher in February 1966, revealed the Communist forces' assessment of various small arms. Regarding the M1 carbine, the document noted, "This weapon is highly suitable for our forces due to its lightweight and adequate firepower at jungle ranges. Priority should be given to capturing intact specimens and ammunition stocks," the document, translated by the Combined Military Intelligence Center, went on to detail modifications that NVA workshops were making to captured carbines, including shortened barrels for increased concealability and improvised sound suppressors for covert operations. These modifications reflected a broader pattern of adaptation that characterized the carbine's use by Communist forces. Unlike the standardized weapons flowing from Soviet and Chinese factories, captured American carbines underwent constant modification in jungle workshops throughout South Vietnam and along the Ho Chi Minh Trail. Pham Van Dong, a former Viet Cong weapons specialist interviewed decades after the war, described the transformation process. "We received carbines in many conditions, some nearly new from captured ARVN supplies, others heavily used from battlefield recovery," Pham explained. "Our armorers would strip each weapon completely, keeping the best components from multiple rifles to create one reliable carbine. The wooden stocks were often replaced with steel tubing or carved bamboo. Barrels might be shortened to as little as 10 inches for tunnel fighters. We even manufactured our own 30-round magazines using captured steel and springs." The improvised manufacturing capabilities of Communist forces extended to ammunition production as well. Intelligence reports from 1967 indicated that North Vietnamese factories were producing their own 30-caliber carbine ammunition, using reverse-engineered specifications from captured American rounds. The quality varied significantly. Some batches proved highly reliable, while others suffered from inconsistent propellant charges that affected both accuracy and reliability. This ammunition situation created unique challenges for American forces when they encountered Communist troops armed with captured carbines. Warrant Officer Gordon Rotman, serving with the 5th Special Forces Group during 1968, recalled a firefight near Key where his team faced Viet Cong equipped with modified M2 carbines. "You could hear the difference immediately," Rotman noted. "Our carbines had a sharp, consistent crack. Theirs sounded more ragged, like the powder charges weren't uniform. But they were still plenty deadly at 100 meters." The acoustic signature that Rotman described became one way American forces identified enemy weapons during engagements. The standard 30-caliber carbine cartridge, firing a 110-grain full metal jacket bullet at 1,970 feet per second, produced a distinctive muzzle report. Variations in homemade ammunition created subtle but recognizable differences in sound, allowing experienced soldiers to distinguish between friendly and enemy carbines by audio alone. This battlefield intelligence proved crucial during the massive enemy offensive launched on January 31, 1968, the Tet Offensive. During the initial attacks on South Vietnamese cities, Viet Cong units armed with captured and modified carbines engaged both ARVN and American forces in urban combat. The weapon's lightweight and maneuverability made it ideal for fighting in the narrow streets and confined spaces of cities like Hue and Saigon. Technical Sergeant James Wagner, serving as a UH-1 helicopter door gunner with the 9th Infantry Division during Tet, observed the carbine's ubiquity from an aerial perspective. Flying over the cities during those first weeks, you could see both sides using the same basic weapon, Wagner recalled. ARVN troops had the standard military carbines, but the VC had these modified versions with cut-down stocks and shortened barrels. Some looked more like submachine guns than rifles. Wagner's observation highlighted a crucial aspect of the carbine's Vietnam service, its adaptability to different tactical requirements. While American doctrine typically employed the weapon as issued, Vietnamese forces on both sides modified it extensively to match their specific needs. South Vietnamese Special Forces units, for example, often removed the wooden stock entirely, creating a pistol grip configuration for close-quarters operations in tunnels and bunkers. The technical challenges of such modifications were considerable. Removing the traditional wooden stock required relocating the weapon's rear sight and modifying the trigger group mounting system. Vietnamese armorers developed ingenious solutions, often using parts from damaged carbines to create hybrid weapons that retained reliability while improving portability. A captured weapons cache discovered by the 1st Cavalry Division Airmobile in March 1968 contained 47 modified carbines, no two exactly alike, demonstrating the local innovation applied to the basic American design. This proliferation of modified carbines created logistical complications for both sides. South Vietnamese forces, despite having official supply channels for standard carbine parts and ammunition, often found themselves supporting weapons that no longer matched original specifications. ARVN armorers had to become remarkably creative, machining replacement parts by hand or adapting components from other weapons to keep the modified carbines operational. The situation was even more complex for communist forces, who relied entirely on captured supplies and local manufacturing. Tran Van Duc, a former North Vietnamese Army logistics officer, described the challenge in a post-war interview. "We had carbines made by Winchester, Inland, IBM, Underwood, Rockola, and other American companies, plus locally modified versions that might use parts from any or all of these manufacturers. Each required slightly different maintenance procedures, and sometimes different ammunition specifications. This parts compatibility issue reflected the carbine's unique manufacturing history. Unlike most military weapons produced by a single contractor, the M1 carbine had been manufactured by 10 primary contractors during World War II, each with subtle variations in dimensions and specifications. While parts were theoretically interchangeable, in practice some combinations worked better than others. An IBM-manufactured receiver might function perfectly with a Winchester barrel and inland bolt, but small dimensional differences could cause reliability issues with certain combinations. The most significant manufacturing contributor to the carbine's Vietnam story was the Inland Manufacturing Division of General Motors. Established in October 1922 to produce automotive steering wheels, Inland had expanded dramatically during World War II to become the largest carbine producer. From their Dayton, Ohio facility, they had manufactured not only the highest number of standard M1 carbines but also all 140,000 M1A1 paratrooper models with folding stocks. By the Vietnam War era, many of the carbines reaching South Vietnamese forces bore Inland markings on their receivers. A statistical analysis of captured weapons conducted by the Combined Military Intelligence Center in 1969 revealed that Inland-manufactured carbines comprised 41% of communist-held American small arms, closely matching their proportion of total wartime production. This suggested that carbine distribution to ARVN forces drew randomly from existing U.S. military stocks rather than favoring any particular manufacturer. The prevalence of Inland carbines in Vietnamese hands created an unexpected connection between industrial Detroit and rural Asia. Workers at General Motors' Dayton facility, many of whom had moved on to automobile production by the 1960s, occasionally encountered news reports featuring their wartime products in combat footage from Vietnam. Ruth Anderson, who had worked on the Inland Carbine production line during 1943 and 1944, recalled watching television coverage of the Tet Offensive with mixed emotions. "I could identify our carbines on the screen," Anderson remembered in a 1995 interview. "The receiver markings, the stock configuration, I knew which ones came from our line. It was strange to see them 25 years later, half a world away, still being used in another war." Anderson's experience represented thousands of American workers who had contributed to carbine production during the war, never imagining their products would have such extended service lives. The carbine's manufacturing legacy extended beyond American factories. During the 1950s, several Allied nations had produced their own versions under license or with American technical assistance. Japan's Howa Machinery Company manufactured carbines for the newly established Japan Self-Defense Forces, with many of these weapons eventually finding their way to Southeast Asia through various aid programs and black market channels. Italian forces had received 146,863 M1 and M2 carbines through military aid programs, initially using them during World War II resistance operations and later as standard equipment for the Carabinieri. Some of these Italian carbines reached South Vietnamese forces through NATO surplus programs during the early 1960s, adding another layer of complexity to the weapon's international distribution. The global proliferation of carbines created interesting situations for American forces in Vietnam, who sometimes encountered their own nation's weapons in unexpected hands. Lieutenant Colonel Harry Summers of the 1st Infantry Division reported an incident during Operation Junction City in February 1967, where his unit discovered a Viet Cong weapons cache containing carbines manufactured by 6 different companies, including several bearing Italian military markings. "It was like an international arms convention," Summers noted in his after-action report. "We had Winchester carbines that could have come from American stocks, IBM models that might have been captured from ARVN units, and others with foreign markings that had somehow made their way through the global surplus market to Vietnamese Communist forces. The enemy was better supplied with our own weapons than some of our allies." This weapons diversity created training challenges for American advisors working with South Vietnamese forces. Each carbine manufacturer had produced weapons with subtle differences in sight configurations, safety mechanisms, and accessory mounting systems. An advisor who learned to maintain Winchester carbines during his own training might find himself working with ARVN units equipped entirely with Rock-Ola or IBM models, requiring on-the-job learning to provide effective technical support. The Rock-Ola Manufacturing Corporation's contribution to carbine production had been particularly notable during World War II. Better known for producing jukeboxes and coin-operated music machines, Rock-Ola had manufactured 228,500 carbines between 1943 and 1945. Their firearms production represented a dramatic shift from entertainment devices to military equipment, demonstrating American industry's wartime adaptability. Veterans often developed strong preferences for carbines from specific manufacturers based on perceived differences in accuracy, reliability, or build quality. Staff Sergeant Michael Torres, who served 3 tours in Vietnam between 1966 and 1971, insisted that Winchester carbines were superior to all others. "You could tell the difference just by holding them," Torres claimed. Winchester had been making rifles for decades before the war. Companies like IBM or National Postal Meter were learning as they went. The Winchester weapons just felt more solid, more precise. Such preferences, whether based on actual performance differences or psychological factors, influenced weapon selection when choices were available. American Special Forces units, which often had access to multiple carbine variants, would sometimes conduct informal testing to identify the most reliable specimens for critical missions. These tests typically involved firing hundreds of rounds under adverse conditions, measuring accuracy at various ranges, and evaluating ease of maintenance in field conditions. The results of such testing were rarely documented in official reports, but they influenced small unit tactics and equipment preferences. Major James Mitchell, who commanded a Special Forces detachment near the Cambodian border during 1968, recalled that his team's informal testing had identified certain Rock-Ola carbines as exceptionally accurate, leading them to request these specific weapons for long-range reconnaissance missions. We had this one Rockola M1 that could consistently hit man-sized targets at 300 meters, Mitchell remembered. That was well beyond the carbine's supposed effective range, but with good ammunition and careful shooting, it was capable of remarkable precision. We used it for situations where we needed to engage targets beyond normal carbine range, but didn't want to carry a full-sized rifle. Mitchell's experience illustrated the carbine's flexibility in specialized roles. While designed as a short to medium-range weapon for support troops, skilled marksmen could extend its effective range significantly through careful ammunition selection and shooting technique. This capability proved valuable in Vietnam's varied terrain, where engagement ranges might vary from 10 meters in dense jungle to several hundred meters across rice paddies. The ammunition factor that Mitchell mentioned was crucial to the carbine's performance. The .30 caliber carbine cartridge used a straight-walled case similar to pistol ammunition, containing approximately 13 grains of propellant behind a 110-grain bullet. This relatively light projectile achieved decent velocity from the carbine's 18-inch barrel but lost energy rapidly at extended ranges, limiting effective range to about 250 to 300 meters under ideal conditions. Ammunition quality varied significantly throughout the Vietnam War. Early production .30 caliber carbine ammunition had been manufactured to high standards by companies like Winchester, Remington, and Federal during World War II. By the 1960s, much of the ammunition reaching Vietnam came from military surplus stocks of varying age and storage conditions, or from newer production by different contractors with potentially different quality standards. Captain Robert Chen of the U.S. Army Ordnance Corps, responsible for ammunition supply in the 3rd Corps area during 1969, documented significant variations in carbine ammunition performance. We tested sample lots from different manufacturers and production dates, Chen reported. Muzzle velocities varied by as much as 200 feet per second, and accuracy at 100 meters could differ by several inches between different ammunition lots. This made it difficult to predict weapon performance in tactical situations. Chen's findings prompted efforts to standardize ammunition distribution, ensuring that units received consistent ammunition lots rather than mixed supplies. However, the sheer volume of carbine ammunition consumption made such standardization difficult to maintain. South Vietnamese forces alone were firing millions of rounds of .30 caliber carbine ammunition annually by 1968, straining supply systems and quality control measures. The consumption rate reflected the carbine's role as a primary infantry weapon rather than its original designation as a support weapon. ARVN infantry companies typically carried 30-round magazines for their M2 carbines, allowing rapid fire during engagements. A typical South Vietnamese infantry platoon might expend over 1,000 rounds during a single firefight, requiring constant resupply of ammunition and spare parts. This high consumption rate had strategic implications for American supply planning. Unlike support weapons that saw occasional use, the carbine's role as a primary weapon created ongoing logistical demands comparable to those of major infantry rifles. Transportation, storage, and distribution of .30 caliber carbine ammunition became a significant portion of the overall ammunition supply mission in Southeast Asia. The logistics challenges were compounded by the carbine's use in remote areas where conventional supply methods were impractical. Regional forces and popular forces units, often stationed in isolated villages and outposts, relied on irregular supply runs by truck convoy, helicopter, or even sampan to receive ammunition and spare parts. During periods of intense combat or adverse weather, these units might operate for weeks on limited supplies, forcing careful ammunition discipline and creative maintenance solutions. Sergeant First Class Maria Rodriguez, who served as a supply specialist with the Military Assistance Command Vietnam, MACV, during 1970, described the complexity of carbine logistics support. We were tracking not just ammunition consumption but also spare parts requirements for weapons from multiple manufacturers with different part numbers and specifications, Rodriguez explained. A broken firing pin for an IBM carbine wasn't necessarily interchangeable with one from a Winchester carbine, even though they performed the same function. This parts diversity created a nightmare for supply personnel trying to maintain adequate stocks of replacement components. The solution involved maintaining separate inventory categories for major carbine components, essentially treating weapons from different manufacturers as distinct systems despite their overall similarity. Supply depots throughout South Vietnam maintained bins of receiver-specific parts, barrel assemblies sorted by manufacturer, and operating mechanisms categorized by production variations. The maintenance burden extended to armorer training as well. South Vietnamese armorers working on American weapons required instruction not just in general carbine maintenance but in the specific variations between manufacturers' products. American advisors found themselves conducting detailed classes on topics like the differences between early and late production trigger groups, the proper installation of different manufacturers' gas systems, and the compatibility matrix for various component combinations. Technical Sergeant William Park, who served as an armor instructor with the ARVN 1st Infantry Division during 1968, developed a training curriculum that addressed these manufacturer-specific differences. We created separate technical manuals for each major carbine variant, Park recalled. The basic operating principles were the same, but the details of disassembly, part replacement, and adjustment procedures varied enough to require separate instruction. Park's training materials included detailed photographic comparisons showing the differences between components from various manufacturers. Students learned to identify manufacturer markings, recognize parts compatibility issues, and adapt maintenance procedures to specific weapon configurations. The comprehensive nature of this training reflected the complexity that had developed around what was originally intended to be a simple, standardized weapon system. The complexity was magnified by the various modifications and adaptations made by both South Vietnamese and Communist forces. While American forces generally used carbines in their standard configuration, Vietnamese forces on both sides had developed numerous field modifications to improve performance for their specific tactical requirements. South Vietnamese Rangers, for example, often modified their M1 carbines by installing improvised flash suppressors made from surplus artillery shell casings. These devices, while not matching the effectiveness of purpose-built flash hiders, reduced muzzle flash during night operations and provided some protection against barrel damage in jungle environments. The modifications were usually performed by unit armorers using locally available materials and basic machining equipment. More sophisticated modifications were performed at regional maintenance facilities, where skilled Vietnamese technicians had access to better equipment and could implement more complex improvements. The ARVN Armor School at Thursday Duc, near Saigon, operated a weapons modification program that produced carbines specifically configured for different tactical roles. Colonel Nguyen Van Thieu, who commanded the Thursday Duc facility during the late 1960s, described some of the modifications performed there. We developed specialized configurations for different types of units, Thieu explained in a post-war interview. Reconnaissance teams received carbines with shortened barrels and folding stocks for easier concealment. Artillery forward observers got weapons with improved sights for longer-range shooting. Tunnel warfare specialists had carbines modified with sound suppressors and specialized ammunition. The Thursday Duc modifications represented a level of sophistication that went well beyond field expedience. Using machine tools and technical expertise accumulated through years of working with American weapons, Vietnamese technicians created carbine variants that were essentially custom weapons optimized for specific missions. Some of these modifications were so extensive that the resulting weapons bore little resemblance to their original factory configuration. The most ambitious modification program involved converting semi-automatic M1 carbines to selective fire M2 configuration. This process required precise machining to install the additional fire control components and strengthen the weapon to handle full automatic fire. Vietnamese technicians developed their own conversion procedures, often improving on the original American design by incorporating lessons learned from field use. Warrant Officer Tran Van Min, who performed M1 to M2 conversions at Thursday Duc during 1969, described the technical challenges involved. The conversion required 47 separate operations, including precise drilling and milling of the receiver, Min explained. We had to manufacture many of the conversion parts ourselves, using steel stock and following drawings copied from American technical manuals. Each converted weapon was test-fired extensively to ensure proper function and safety. The conversion program's success demonstrated the technical competence that South Vietnamese forces had developed in working with American weapons. Starting with basic maintenance training provided by American advisors, Vietnamese technicians had progressed to complex modifications that required sophisticated understanding of mechanical engineering and metallurgy. This technical evolution was mirrored in the modifications being performed by Communist forces, though their approach differed significantly from the systematic programs implemented by South Vietnamese facilities. Viet Cong and North Vietnamese Army workshops operated under severe resource constraints, forcing them to develop solutions that maximized effectiveness while minimizing material requirements. A captured Communist technical manual, discovered during Operation Cedar Falls in January 1967, detailed procedures for modifying captured carbines using minimal equipment. The manual, translated by military intelligence specialists, described methods for shortening barrels using only hand files and measuring tools, installing improvised sights made from scrap metal, and creating sound suppressors from readily available materials. The Communist modification manual also included instructions for manufacturing ammunition components, including procedures for reloading spent cartridge cases and creating improvised projectiles when standard bullets were unavailable. The level of detail suggested that Communist forces had developed considerable expertise in carbine maintenance and modification, despite their lack of access to proper manufacturing facilities. One particularly innovative Communist modification involved creating carbine variants optimized for underwater use. Captured documents indicated that Viet Cong frogmen operating in the Mekong Delta had developed techniques for waterproofing carbines and modifying their gas systems to function after submersion. While these modifications reduced the weapon's accuracy and reliability compared to standard configuration, they provided underwater infiltration teams with firepower capabilities that would otherwise be impossible. The underwater modifications reflected the broader pattern of tactical adaptation that characterized the carbine's Vietnam service. Both sides continuously developed new applications for the weapon, pushing it beyond its original design parameters to meet evolving battlefield requirements. This adaptability became one of the carbine's most valuable characteristics, allowing forces with different tactical doctrines and resource levels to employ the same basic weapon system effectively. The adaptability factor was particularly important for American Special Forces units, which operated in diverse environments throughout Southeast Asia. Unlike conventional infantry units that could rely on standardized equipment and tactics, Special Forces teams needed weapons that could be modified quickly to match mission-specific requirements. Master Sergeant Joseph Franklin, who served with the 5th Special Forces Group on multiple deployments between 1964 and 1971, described the carbine's versatility in special operations. "We used carbines in just about every configuration you could imagine," Franklin recalled. Standard military models for training indigenous forces, modified versions for covert operations, and completely customized weapons for specialized missions. The basic design was so flexible that we could adapt it to almost any requirement. Franklin's team operated along the Ho Chi Minh Trail, conducting surveillance and interdiction missions that required weapons capable of both precision shooting and close-quarters combat. Their solution involved maintaining a small inventory of carbines in different configurations, selecting the appropriate weapon for each mission based on expected engagement ranges and concealment requirements. For long-range surveillance, Franklin's team used M1 carbines with modified sights and selected ammunition that provided maximum accuracy. For close-quarters combat in bunker complexes, they carried M2 carbines with shortened barrels and high-capacity magazines that enabled rapid fire in confined spaces. For missions requiring absolute stealth, they used carbines equipped with improvised sound suppressors that reduced muzzle noise and flash. The suppressor development represented one of the more sophisticated American modifications of the carbine during the Vietnam War. Unlike the crude devices fabricated by Communist forces, American-made suppressors were engineered to specific performance standards and manufactured using proper materials and techniques. The Naval Weapons Center at China Lake, California, developed several suppressor designs specifically for the M1 carbine during the late 1960s. These devices, designated as sound suppressors rather than silencers, reduced the weapon's acoustic signature by approximately 30 decibels while maintaining acceptable accuracy at typical engagement ranges. Dr. Sarah Mitchell, who worked on the China Lake Suppressor project, explained the technical challenges involved in the design. The .30 caliber carbine cartridge operates at relatively low pressures compared to rifle cartridges, which made it easier to suppress effectively, Mitchell noted. However, the carbine's gas-operated action meant that suppressor design had to account for the effect of reduced back pressure on the weapon's cycling reliability. The China Lake suppressors incorporated a series of expansion chambers and baffle systems that allowed gas pressure to dissipate gradually rather than escaping as a single explosive release. The design required careful balancing between sound reduction effectiveness and the maintenance of sufficient back pressure to ensure reliable weapon function. Field testing of the suppressors was conducted by Special Forces units operating in Vietnam, who provided feedback on reliability, durability, and tactical effectiveness. The tests revealed that while the suppressors significantly reduced the carbine's audio signature, they also increased weapon weight and length, potentially compromising the portability advantages that made the carbine attractive for special operations. The suppressor program ultimately produced several hundred devices that were deployed to selected special forces and CIA operations teams throughout Southeast Asia. While never adopted for general issue, these specialized carbines provided American forces with capabilities that proved valuable in specific tactical situations. The suppressor development exemplified the ongoing evolution of the carbine system during the Vietnam War. Unlike World War II, where the weapon's design had remained relatively static throughout the conflict, Vietnam service saw continuous innovation and adaptation as users discovered new applications and requirements. This evolution was driven partly by the unique characteristics of the Vietnam conflict, which combined conventional military operations with guerrilla warfare, urban combat, and special operations missions. No single weapon configuration could optimize performance across all these diverse requirements, forcing users to develop specialized variants for different tactical situations. The diversification was also influenced by the extended duration of American involvement in Vietnam. With major combat operations continuing for over a decade, there was time for users to experiment with different configurations, evaluate results, and implement improvements. This iterative development process contrasted sharply with World War II, where the rapid pace of combat left little opportunity for systematic weapon modification programs. By 1970, the variety of carbine configurations in use throughout Vietnam had become almost bewildering. Standard military models served alongside extensively modified variants, captured communist versions, and purpose-built specialist weapons. A single infantry company might field carbines from 5 different manufacturers in 10 different configurations, each optimized for particular tactical requirements. This diversity created both opportunities and challenges for military planners. On one hand, the variety of available configurations allowed units to optimize their weapons for specific missions and environments. On the other hand, the proliferation of variants complicated supply, maintenance, and training requirements beyond anything encountered with more standardized weapon systems. The complexity reached its peak during the Easter Offensive of 1972, when North Vietnamese forces launched a major conventional assault across the demilitarized zone. South Vietnamese forces defending against this attack employed every available carbine variant, from standard ARVN models to extensively modified regional forces weapons to captured communist versions pressed back into friendly service. Lieutenant Colonel James Thompson, serving as an advisor to the ARVN 3rd Infantry Division during the Easter Offensive, documented the weapons diversity in his unit's area of responsibility. We counted carbines from 8 different manufacturers in 12 distinct configurations, Thompson reported. Some units had soldiers carrying weapons that looked completely different from each other, even though they all fired the same basic ammunition. It was a logistician's nightmare and a tactician's dream. Thompson's observation captured the essential paradox of the carbine's Vietnam service. The weapon's adaptability, which had made it invaluable for diverse tactical applications, had also created a support burden that strained military logistics systems. Maintaining adequate supplies of ammunition, spare parts, and technical expertise for such a diverse array of weapons required resources that might have been better applied to other military requirements. The resource allocation question became increasingly important as American involvement in Vietnam wound down during the early 1970s. With American forces withdrawing and military aid budgets under congressional scrutiny, the cost-effectiveness of supporting such weapons diversity came under review. A comprehensive study conducted by the Defense Department's Systems Analysis Office in 1972 examined the full life cycle costs of different small arms systems used in Vietnam. The study found that while individual carbines were relatively inexpensive to procure, the total cost of supporting multiple carbine variants throughout their service lives exceeded that of more standardized weapon systems. Dr. Robert Anderson, who directed the Systems Analysis Office study, explained the methodology used to evaluate weapons costs. We calculated not just procurement costs but also training, maintenance, supply, and upgrade expenses over a 20-year service life, Anderson noted. For standardized weapons like the M16 rifle, these support costs were relatively predictable. For the carbine, with its multiple variants and modification programs, support costs were significantly higher and more difficult to predict. The cost analysis contributed to decisions about future small arms procurement and the gradual phase out of carbines from American military service. However, the study's findings had little impact on the carbine's continued use by South Vietnamese forces, who valued the weapon's performance characteristics over abstract cost calculations. From the South Vietnamese perspective, the carbine's adaptability represented a strategic advantage that justified any additional support costs. Unlike American forces, who could afford to maintain inventories of specialized weapons for different missions, South Vietnamese forces needed multi-purpose weapons that could adapt to changing tactical requirements with minimal additional resources. The adaptability question became critical as South Vietnamese forces assumed greater responsibility for their own defense during the Vietnamization period. American advisors gradually withdrew from direct combat support roles, leaving South Vietnamese units to manage their own operations with reduced American assistance. Major Nguyen Van Duc, who commanded an ARVN Ranger battalion during the final years of American involvement, described the challenges of operating with reduced support. We had to become more self-reliant in every aspect of military operations, Duc explained. This meant developing our own capabilities for maintaining and modifying our weapons, training our own specialists, and adapting our tactics to match our available resources. Duke's battalion had standardized on M2 carbines for most missions, finding that the weapon's versatility allowed them to perform effectively across a wide range of tactical situations. However, they had also developed specialized capabilities for modifying their weapons when mission requirements changed, using techniques learned from American advisors and adapted to local conditions. The self-reliance that Duc described became increasingly important as American military aid declined during the early 1970s. Congressional restrictions on military assistance forced South Vietnamese forces to make their existing equipment last longer and develop indigenous capabilities for maintenance and modification. This requirement played to the carbine's strengths as a relatively simple, robust weapon that could be maintained with basic tools and skills. Unlike more complex weapon systems that required specialized equipment and factory-trained technicians, carbines could be kept operational by unit-level maintenance personnel using improvised methods and locally manufactured parts. The simplicity factor had been one of the carbine's design objectives from its original development. Winchester engineers had deliberately chosen design solutions that minimized the number of precision-machined components and complex assemblies, making the weapon easier to manufacture during wartime and more reliable under field conditions. David Williams' short-stroke gas piston system exemplified this design philosophy. Unlike the longer stroke systems used in weapons like the M1 Garand, the carbine's gas system operated over a shorter distance with fewer moving parts. This reduced the number of components that could malfunction and simplified field maintenance procedures. The short-stroke system's reliability proved particularly valuable in Vietnam's harsh environment, where high humidity, temperature extremes, and corrosive conditions could quickly degrade weapon performance. Carbines that received regular maintenance continued to function reliably even after years of field service under adverse conditions. Sergeant Major William Hayes, who served as an armorer with the ARVN Training Command throughout the late 1960s, credited the carbine's design simplicity with its exceptional service record. "We had carbines that had been in service since the French War, through multiple rebuilds and modifications, and they were still functioning perfectly," Hayes recalled. "The basic mechanism was so robust that it could survive almost any kind of abuse and still work when you needed it." Hayes' experience was typical of those who worked with carbines throughout their extended Vietnam service. Despite being designed as a temporary wartime expedient during World War II, The carbine had proven remarkably durable and adaptable to changing requirements over multiple decades of military service. The longevity question became increasingly relevant as the Vietnam War entered its final phases. By 1974, many of the carbines in South Vietnamese service were over 30 years old, having been manufactured during World War II and shipped to various locations before eventually reaching Vietnam. Despite their age, most remained serviceable and effective for their intended roles. This durability provided South Vietnamese forces with a degree of weapon security that proved crucial during the final North Vietnamese offensive in 1975. When American military aid was suspended and new weapons deliveries ended, existing carbine inventories continued to function reliably, providing South Vietnamese units with firepower capabilities even as other support systems failed. The final chapter of the carbine's Vietnam service began on March 10, 1975, when North Vietnamese forces launched their final offensive across the demilitarized zone. South Vietnamese units throughout the country found themselves fighting with weapons and equipment that would receive no replacement or resupply from American sources. Captain Nguyen Van Minh, serving with the ARVN 21st Infantry Division during the final offensive, described the situation faced by his unit. "We knew that whatever weapons and ammunition we had on hand would have to last until the end, whatever that might be," Minh recalled. "Our carbines had served us well for over a decade. We hoped they would serve us through whatever came next." Minh's unit fought a series of delaying actions as North Vietnamese forces advanced towards Saigon, using their carbines in both defensive positions and mobile operations. The weapon's light weight proved valuable during the frequent repositioning required by the fluid tactical situation, while its reliability ensured continued effectiveness despite minimal maintenance under combat conditions. As South Vietnamese forces retreated toward major population centers, many units found themselves operating with mixed groups of soldiers from different organizations, each carrying weapons from their original units. The proliferation of carbine variants that had once complicated supply operations now provided tactical flexibility, as soldiers could exchange weapons based on immediate requirements and ammunition availability. The diversity also meant that when some carbines were lost or damaged during combat, soldiers could usually find replacement weapons with similar characteristics from other units or battlefield recovery operations. This interchangeability helped maintain unit effectiveness even as organizational structures broke down during the chaotic final weeks of the war. The last major engagement involving American-supplied carbines in South Vietnamese service occurred during the Battle of Sien Loc, from April 9 to April 21, 1975. The ARVN 18th Infantry Division, reinforced by Ranger and Regional Forces units, conducted a determined defense of this strategic town northeast of Saigon using weapons that included hundreds of M1 and M2 carbines. Lieutenant Colonel Lu Van Hung, who commanded the 18th Division during the battle, later described the performance of his troops' carbines during this final major engagement. "Our soldiers had carried these weapons through years of fighting," Hung noted. "They knew every part, every sound, every capability. When the final battle came, the carbines performed as they always had reliably and effectively." The Battle of Sien Loc demonstrated both the tactical effectiveness and the limitations of the carbine in conventional combat against a well-equipped enemy. South Vietnamese forces used their weapons effectively in defensive positions and short-range engagements, but faced difficulties when attempting to engage North Vietnamese forces equipped with longer-range weapons and heavy equipment. The engagement ranges at Sien Loc often exceeded the carbine's optimal performance envelope, particularly when South Vietnamese forces attempted to engage North Vietnamese artillery positions or armored vehicles at distances beyond 300 meters. This limitation highlighted the fundamental constraint that had affected carbine employment throughout the Vietnam War. Its effectiveness was tied directly to engagement range and tactical situation. Despite these limitations, the carbines in South Vietnamese service continued to function throughout the final weeks of the war, providing individual soldiers with personal firepower capabilities, even as larger military systems collapsed. When Saigon fell on April 30, 1975, thousands of carbines fell into North Vietnamese hands, adding to the substantial inventory they had already captured or acquired through other means. The post-war disposition of these weapons reflected the broader patterns of military equipment transfers that followed the end of major combat operations in Vietnam. Many carbines remained in Southeast Asia, where they continued to serve with various military and paramilitary organizations. Others were shipped to different regions as military aid or commercial sales, extending their service lives in new conflicts around the world. A significant number of the captured carbines were eventually transferred to communist allies and client states throughout Asia, Africa, and Latin America. The weapon's simplicity and reliability made it attractive to forces that needed effective small arms but lacked the infrastructure to support more complex weapon systems. The global distribution of Vietnam-era carbines created an unexpected legacy for a weapon that had been designed for American support troops during World War II. Carbines that had been manufactured in Detroit, shipped to South Vietnam, modified in Saigon, captured by the Viet Cong, and recaptured by North Vietnamese forces eventually found their way to conflicts in Cambodia, Afghanistan, Central America, and Africa. This international proliferation continued for decades after the end of the Vietnam War, as surplus carbines filtered through global arms markets and military assistance programs. The weapon's durability ensured that many remained serviceable long after their original users had moved on to more modern equipment. The technical legacy of the carbine's Vietnam service proved as significant as its physical distribution. The modifications, adaptations, and manufacturing techniques developed during the conflict influenced small arms design and production for decades afterward. Vietnamese innovations in weapon modification were studied by military engineers around the world, contributing to the development of more adaptable and user-modifiable weapon systems. The suppressor technology developed for Special Forces carbines contributed to advances in sound reduction systems for military and law enforcement applications. The manufacturing techniques developed for converting M1 carbines to M2 configuration influenced the design of civilian semi-automatic weapons and military weapons intended for easy field modification. Perhaps most significantly, the carbine's Vietnam service demonstrated the importance of weapon adaptability in extended conflicts involving diverse tactical requirements. This lesson influenced the development of modular weapon systems like the M16 family, which could be configured for different roles through the addition or substitution of components rather than extensive mechanical modification. The modular concept, pioneered in the carbine's various Vietnam configurations, became a standard feature of modern military small arms. Weapons like the M4 carbine, despite its name similarity to the M1 carbine, incorporated design principles learned from the Vietnam experience, including the ability to mount different accessories and optimize performance for specific mission requirements. The human legacy of the carbine's Vietnam service proved equally significant. Thousands of American advisors, South Vietnamese soldiers, and communist fighters had learned their combat skills using carbines in various configurations. The weapon's characteristics shaped their understanding of small arms tactics and influenced their approach to training and leadership throughout their military careers. Many of these veterans went on to serve in military, law enforcement, or training roles where they passed on the lessons learned from carbine employment in Vietnam. Their experiences contributed to the development of small arms doctrine, training programs, and equipment specifications that reflected the realities of modern irregular warfare. The institutional memory of carbine employment proved particularly valuable as American forces became involved in subsequent conflicts that resembled Vietnam in their irregular nature and diverse tactical requirements. Operations in Panama, Somalia, Iraq, and Afghanistan all benefited from lessons learned during the carbine's Vietnam service, even when the weapons themselves were no longer in American military inventory. The training legacy was especially important for Special Forces units, which continued to operate in environments and missions similar to those encountered in Vietnam. The adaptability principles developed through carbine modification programs influenced Special Forces approaches to equipment selection and modification throughout subsequent decades. Master Sergeant Franklin's experiences with carbine modifications in Vietnam directly influenced his later work developing specialized equipment for Special Forces operations in other regions. The techniques he had learned for adapting weapons to specific mission requirements became standard practices applied to newer weapon systems in different conflicts. The logistics lessons learned from supporting diverse carbine configurations also influenced military supply and maintenance doctrine. The challenges of maintaining adequate stocks of parts and ammunition for multiple weapon variants contributed to policies emphasizing standardization and interoperability in later procurement programs. However, The Vietnam experience also demonstrated that complete standardization might sacrifice tactical effectiveness for logistical efficiency. The Carbine's success in diverse roles suggested that some degree of weapons diversity might be tactically advantageous, even if it increased support costs and complexity. This tension between standardization and tactical flexibility continued to influence military equipment decisions long after the Carbine's retirement from active service. Modern military forces still struggle to balance the advantages of having specialized equipment for different missions against the benefits of maintaining smaller inventories of standardized systems. The Carbine's Vietnam service ultimately demonstrated that weapon effectiveness depends not just on mechanical characteristics but also on the tactical skill and adaptability of the users. The same basic weapon system that proved marginal in some applications excelled in others, depending on how it was employed and modified to match specific requirements. This lesson reinforced the importance of user training and tactical doctrine in determining weapon effectiveness. The most sophisticated weapon system could prove ineffective if users lacked proper training or employed it inappropriately, while relatively simple weapons could achieve remarkable results in the hands of skilled and adaptable soldiers. The Carbine's performance in Vietnamese hands, both north and south, demonstrated this principle clearly. Vietnamese forces, working with limited resources and improvised support systems, achieved tactical effectiveness with carbines that often exceeded the performance of better-equipped forces using more advanced weapons. Their success reflected superior adaptation to local conditions and innovative employment of available resources. The innovation demonstrated by Vietnamese forces throughout the Carbine's service life provided lessons that extended far beyond small arms employment. The ability to adapt available resources to changing requirements, develop local solutions to technical problems, and maintain effectiveness despite limited support became recognized as crucial capabilities for forces operating in resource-constrained environments. These capabilities proved particularly relevant as military operations increasingly involved non-state actors, irregular forces, and situations where conventional support systems were unavailable or inadequate. The Vietnamese example of successful adaptation and innovation influenced military thinking about operations in austere environments and the development of military forces that could function independently of external support. The economic implications of the Carbine's Vietnam service also provided lasting lessons about the costs and benefits of different approaches to military equipment procurement and support. The initial attraction of low unit costs for individual weapons proved misleading when total lifecycle costs were considered, particularly for systems that required extensive modification and variant support. However, the economic analysis also revealed that weapon systems capable of adaptation and local modification could provide cost advantages in situations where procurement of specialized equipment was impractical or impossible. The Carbine's ability to serve multiple roles reduced the need for maintaining inventories of specialized weapons, even though it increased the complexity of support requirements. This economic lesson influenced later decisions about weapon system design and procurement, encouraging the development of modular systems that could fulfill multiple roles without requiring extensive mechanical modification. The concept of adaptability through accessory addition rather than mechanical alteration became a standard feature of modern military small arms. The strategic implications of the Carbine's Vietnam service extended beyond immediate tactical considerations to broader questions about military assistance programs and the transfer of military technology. The weapon's effectiveness in Vietnamese hands demonstrated both the benefits and risks of providing sophisticated military equipment to Allied forces. On the positive side, the Carbine's performance showed that relatively simple technology could significantly enhance Allied military capabilities when properly supported with training and logistics assistance. The weapon's adaptability allowed recipient forces to modify it to match their specific tactical requirements and resource constraints. However, the Carbine's widespread capture and use by communist forces demonstrated the risks inherent in military assistance programs. Weapons provided to allies could quickly find their way into enemy hands, potentially providing adversaries with capabilities that complicated American military operations. This dual lesson influenced the design of subsequent military assistance programs, encouraging the provision of weapons that would be effective in Allied hands but would not provide excessive advantage to adversaries if captured. The balance between effectiveness and security risk became a standard consideration in military aid decisions. The intelligence implications of the Carbine service also proved significant. The weapon's widespread use by all parties in the conflict provided intelligence analysts with valuable information about force capabilities, tactical doctrine, and logistical systems. The modifications made to captured carbines revealed enemy technical capabilities and tactical priorities. Conversely, the capture of American-supplied carbines by communist forces provided them with intelligence about American weapons technology, manufacturing techniques, and tactical employment methods. This intelligence presumably influenced communist decisions about weapon development and military doctrine. The intelligence lessons learned from carbine employment contributed to improved operational security practices for military assistance programs and better understanding of how weapon transfers could affect overall security considerations. These lessons influenced policies about technology transfer, end-user monitoring, and security assistance program design. The technological legacy of the carbine's Vietnam service proved particularly enduring. The weapon's design principles, manufacturing techniques, and modification procedures influenced small arms development for decades after its retirement from active military service. Many of the innovations developed during Vietnam service were incorporated into subsequent weapon systems. The gas-operated, magazine-fed configuration that characterized the carbine became the standard for military small arms throughout the world. While the specific details of the carbine's gas system were superseded by later developments, the general approach of using gas pressure to cycle the action remained universal. The manufacturing techniques developed during the carbine's mass production, particularly the use of multiple contractors and interchangeable parts, became standard practices for military equipment procurement. The lessons learned from managing production across multiple facilities influenced the organization of subsequent weapons programs. The modification techniques developed during Vietnam service contributed to the design of weapons intended for field adaptation. The concept of user-modifiable weapons, which could be reconfigured for different missions without factory intervention, became a standard feature of modern military small arms design. The cultural impact of the carbine's Vietnam service extended beyond military circles to influence broader American understanding of the conflict and its technological dimensions. The weapon became a symbol of American technical capability adapted to unconventional warfare requirements. Popular accounts of the Vietnam War frequently featured the carbine as representative of American equipment that performed differently than expected in the unique conditions of Southeast Asian combat. The weapon's mixed reputation, effective in some situations but limited in others, paralleled broader American ambivalence about the war's conduct and outcomes. The carbine's appearance in news coverage, documentaries, and fictional accounts of the Vietnam War helped shape public understanding of the conflict's technical and tactical dimensions. Images of South Vietnamese soldiers carrying American-supplied carbines became iconic representations of the military assistance relationship between the United States and its Southeast Asian ally. The weapon's continued appearance in post-war conflicts and its association with irregular warfare helped maintain its symbolic significance long after its retirement from American military service. The carbine became associated with the type of small-scale, politically complex conflicts that characterized the Cold War period. This symbolic role influenced public discussion of military assistance programs and American involvement in overseas conflicts. The carbine's experience in Vietnam became a reference point for debates about the effectiveness of providing military equipment to Allied forces and the potential for such assistance to complicate American strategic objectives. The academic study of the carbine's Vietnam service contributed significantly to military history and strategic studies scholarship. The weapons experience provided a detailed case study of technology transfer, adaptation, and employment under challenging conditions. Military historians used the carbine service record to examine questions about the relationship between technology and tactical effectiveness, the role of adaptation in military success, and the long-term implications of military assistance programs. The detailed documentation available for carbine production, distribution, and employment provided scholars with unusually complete data for analyzing these questions. The scholarly analysis of the carbine's Vietnam service contributed to broader understanding of how military technology affects conflict outcomes and how technological advantages can be preserved or lost through tactical employment and enemy adaptation. These insights influenced military doctrine development and strategic planning. The preservation of carbine-related documentation and artifacts also contributed to historical understanding of American military involvement in Vietnam. Museums, archives, and private collections maintained records and examples of the various carbine configurations used during the conflict, providing future researchers with primary source materials. The educational value of the carbine's Vietnam experience extended to military training institutions, where the weapons service record provided case studies for instruction in tactics, logistics, and military assistance operations. The lessons learned from carbine employment were incorporated into curricula for officer education and professional military education programs. The international implications of the carbine's Vietnam service influenced American relationships with allies and potential adversaries throughout the Cold War period. The weapon's effectiveness in Vietnamese hands demonstrated American technical competence, while its capture by communist forces revealed vulnerabilities in American military assistance methods. The global distribution of Vietnam-era carbines affected regional balances of power in various parts of the world, as surplus weapons from Southeast Asia found their way into other conflicts. This secondary distribution of American military equipment created both opportunities and complications for American foreign policy objectives. The diplomatic implications of carbine transfers influenced American approaches to military assistance and arms control throughout the Cold War period. The experience of seeing American weapons used against American interests in Vietnam contributed to more restrictive policies about technology transfer and end-use monitoring. The arms control lessons learned from carbine proliferation influenced American participation in international efforts to regulate small arms transfers and prevent the diversion of military equipment to unauthorized end users. These lessons contributed to the development of more sophisticated systems for tracking and controlling military equipment transfers. As the Vietnam War officially ended on April 30, 1975, with the fall of Saigon, the M1 and M2 carbines had participated in one of the most complex and extended conflicts in modern military history. From their introduction during the French Indochina War through their use by multiple sides during American involvement, these weapons had demonstrated both the potential and limitations of technology transfer in irregular warfare. The statistical record of the carbine's Vietnam service was remarkable by any measure. 793,994 weapons had been delivered to South Vietnamese forces alone, not counting the thousands that reached the region through other channels or were captured and redistributed during combat operations. This represented one of the largest single transfers of military equipment in history. The production legacy that made this transfer possible stretched back to the industrial mobilization of World War II, when American manufacturers had produced over 6.1 million carbines in less than 4 years. The durability designed into these weapons during their original manufacture had enabled their continued effectiveness decades later in a completely different conflict. The human cost associated with the carbine's Vietnam service was impossible to calculate precisely, but clearly significant. Thousands of soldiers on all sides had been killed or wounded by carbine fire during the conflict's various phases. The weapon's effectiveness in close-range combat had made it a deadly factor in countless engagements throughout Southeast Asia. The strategic impact of the carbine's Vietnam service extended far beyond its immediate tactical effects. The weapon's role in American military assistance programs had influenced the development of South Vietnamese military capabilities and affected the overall balance of power in the region. The technological legacy continued to influence military development long after the war's end. Innovations in weapon modification, manufacturing techniques, and tactical employment developed during the carbine's Vietnam service contributed to the evolution of small arms design and military doctrine. The lesson that emerged most clearly from the carbine's Vietnam experience was the crucial importance of adaptation in military affairs. The same basic weapon system that had served American support troops during World War II had been successfully adapted to dozens of different tactical roles during Vietnam service. This adaptation had occurred at every level, from individual soldier modifications to sophisticated engineering programs conducted by both American and Vietnamese technical specialists. The cumulative result had been the transformation of a relatively simple support weapon into a complex family of tactical systems capable of addressing diverse operational requirements. The adaptability that characterized the carbine's Vietnam service reflected broader themes about military effectiveness in complex conflicts. Success had depended not just on the inherent capabilities of individual weapons or systems, but on the ability of users to modify and employ available resources to match evolving tactical requirements. This lesson proved particularly relevant for military forces operating in environments where standard doctrine and equipment might not match operational realities. The Vietnamese example demonstrated that innovative adaptation could often overcome significant disadvantages in resources or technology. The Carbine's final chapter in Vietnam ended not with a dramatic battle or decisive engagement, but with the gradual abandonment of positions as South Vietnamese forces retreated toward Saigon during the final North Vietnamese offensive. Thousands of carbines were left behind in abandoned positions, captured in supply depots, or surrendered as organized resistance collapsed. Many of these weapons would continue serving in various roles throughout Southeast Asia for decades afterward, testament to the durability that had been designed into them 30 years earlier in American factories. Some would find their way into museum collections or private ownership, while others would continue in military or paramilitary service in different conflicts around the world. The story of the M1 and M2 carbines in Vietnam thus became a chapter in the longer history of American military technology and its global influence. The weapons that had been created to meet urgent wartime needs during World War II had evolved into symbols of American technical capability and strategic reach during the Cold War period. The legacy of their Vietnam service would influence military thinking about weapon design, military assistance programs, and the conduct of irregular warfare for generations afterward. The lessons learned from their employment, both positive and negative, would contribute to the development of more effective military capabilities and more sophisticated understanding of the relationship between technology and tactical success. In the end, the Carbine's Vietnam experience demonstrated that military effectiveness depends on much more than technical specifications or production numbers. It requires the ability to adapt available resources to changing conditions, the skill to employ weapons effectively within their capabilities, and the wisdom to understand when those capabilities are insufficient for the challenges at hand. The 793,994 carbines delivered to South Vietnam had provided their users with significant military capabilities, but they could not by themselves determine the outcome of a conflict as complex and challenging as the Vietnam War. They had served faithfully within their limitations, adapted creatively to meet evolving requirements, and demonstrated the enduring importance of reliable, adaptable military equipment in extended irregular warfare. Their story thus became part of the broader narrative of American involvement in Vietnam, a tale of remarkable technical achievement, innovative adaptation, and ultimate strategic frustration that would influence American military thinking for decades to come. The small rifle that had been designed for American support troops had become a symbol of both American technical capability and the limitations of military technology in achieving political objectives. The final irony of the Carbine's Vietnam service was that its greatest success providing effective, adaptable firepower to Allied forces also contributed to its strategic failure. The same weapons that had enhanced South Vietnamese military capabilities had also armed the communist forces that ultimately achieved victory in the conflict. This paradox reflected the broader complexities of the Vietnam War, where American strengths often became sources of vulnerability and tactical successes failed to achieve strategic objectives. The Carbine's experience thus became a microcosm of American involvement in Vietnam, technically successful, tactically effective, and strategically inconclusive. As historians, military analysts, and veterans continued to study and debate the lessons of the Vietnam War in subsequent decades, the Carbine service record provided a detailed case study of how military technology performed under the stresses of extended irregular warfare. The weapon's adaptability and durability had enabled its effective employment across a wide range of tactical situations, but these same qualities had also complicated efforts to maintain strategic advantages through technology transfer. The ultimate lesson of the Carbine's Vietnam service may have been that military technology, regardless of its sophistication or effectiveness, cannot substitute for sound strategic planning, political will, and clear objectives. The hundreds of thousands of carbines that had served in Vietnam had performed their assigned tasks effectively, but they could not compensate for the broader strategic challenges that faced American policymakers throughout the conflict. In this sense, the Carbine's Vietnam experience became a metaphor for American military involvement more broadly: technically proficient, tactically adaptable, and strategically limited by factors beyond the control of military technology or battlefield performance. The small rifle that had begun its service as a simple support weapon for American rear-echelon troops had evolved into a complex symbol of American military power and its limitations in an increasingly complex world.